Tuples. In this video, we will learn our first data structure. So far in this course, we've learned about the four basic pieces of information. We've learned about the string. We've learned about integers. We've learned about floating point numbers. And we've learned about booleans. That being said, in the real world, information rarely takes the form of just a single string value, or just a single integer, or just a single float, or a single boolean, so on and so forth. Usually, real-world information is more complicated than that. For example, suppose you are a programmer for the school district and you want to store information about a student. That means you're going to need to store a first name, a last name, a grade, birthday information, health information. Is that student allergic to anything or not? So on and so forth. The possibilities are endless. The main point here is that if I want to store information about one student, in order to do that, I'm going to need more than just one string, or just one integer, or just one floating point number, or just one Boolean value. What I'm going to need is a data structure. A data structure is a structure that stores more than one piece of information at a time. Sidebar: if you were to Google the definition of data structure, you would find a much more complex and elaborate definition for the term data structure. And when you move on to more advanced computer science classes in the future, that definition will become more relevant to you. But for now, for this course, all you need to know is that a data structure is a structure that stores more than one piece of information at a time. And that piece of information could be a string, it could be an integer, it could be a floating point number, it could be a Boolean. In general, strings, integers, floating point numbers, and Booleans are the building blocks of data structures. And the first data structure we will learn about in this unit is the tuple. To understand why a tuple would come in handy, consider the following situation. Suppose I want to store information about a data point on a graph. As you know, all points have an x-coordinate and a y-coordinate. So, one way I could store information about this 2D point would be to have two variables, one for the x-coordinate and one for the y-coordinate. However, this approach is kind of messy because we're having to use two variables to keep track of what's really just one thing. It's kind of like if your math teacher asked you to have a binder for every single homework assignment. Would you rather have an individual binder for every single homework assignment, or would you rather have one binder that holds all of your homework assignments? Obviously, life would be much easier if you only had to keep track of just one binder that holds all of your homework. Similarly, in this situation where we are wanting to store information about one individual point, it'd be much easier to have just one variable that stores all the information about that one point, as opposed to having to track multiple variables for each piece of information. So, with that in mind, another solution might be to store the information inside of a string. Now we have everything inside one variable. The issue with this, however, is that pulling out the individual pieces of information is a messy process. For example, suppose I want to compute the distance between this point and another point. Well, first I'll need to locate the index of the comma. Then I'll need to use slicing to pull out the individual coordinates. Then I will need to use the int method to convert the strings to an integer. All of that work, and we haven't even started to compute the distance yet. So in summary, while the string variable did give us a way to keep all the information inside one variable, what it did not provide was easy access to the individual pieces of information. This is where tuples come in. So, how do we make a tuple? At the very least, we're going to need a set of parentheses. The parentheses lets the Python interpreter know that we're creating a tuple variable. Then, inside the parentheses will be the individual pieces of information that we want the tuple to store. In this case, we want two integers, one for the x-coordinate and the other for the y-coordinate. And that gives us our first tuple. Now, you might be thinking that because we're using parentheses, that this looks like a method call, but not at all. Had we been calling a method, then there would be a name in front of the parentheses. But since there is no name in front of the parentheses, the Python interpreter will interpret this as us creating a tuple object. So, now that I'm working with the tuple variable, extracting the individual pieces of information is now simple. All I have to do is use indexing. All right, if I want the first piece of information, I just index 0. If I want the second piece of information, I just index 1. If there was a third piece of information and I wanted to extract that, I would just index 2, so on and so forth. I don't have to worry about the location of the comma like I would if I was using a string variable. I also don't have to convert from a string because the information was already stored inside the tuple as an integer. That being said, if I want to extract multiple pieces of information at the same time, I can use slicing with the tuple the same way as I would with a string. When you use slicing on a tuple variable, the Python interpreter creates a new tuple containing the information that you sliced out. However, if you extract just one piece of information at a time, the Python interpreter won't create a tuple for just that one piece of information. It's just going to pull out that one value. Python also allows you to compute the length of a tuple. All this does is return the number of pieces of information that the tuple is storing. In this case, that is 2. Python also allows you to concatenate tuples. For example, suppose I create another tuple containing the values 4 and 6. I can concatenate them together to produce one tuple storing all 4 of those values. Okay? In this example, I concatenated 2 tuple variables. I can also concatenate a tuple with a tuple literal. In this case, it'll do the same thing. Once again, it'll take the 2 values inside chord 1 and the 2 values inside the tuple literal, which are 8 and 9, and place them all inside one tuple. In summary, what is a tuple? A tuple is a heterogeneous, immutable data type that stores an ordered sequence of data. Obviously, that's a lot to chew on, so let's break it down. First off, what is heterogeneous? Heterogeneous means that the individual pieces of data do not have to be the same data type. And here's what I mean by that. Consider the following tuple. Here, this tuple contains both integers and a string. The first 2 pieces of data are integers, while the third piece of data is a string. Here's another example. Here, the tuple has an integer, a floating point value, and a boolean. In this third example, we have a string, a floating point, and a boolean. In summary, the individual pieces of data inside a tuple variable do not have to be the same type, thus making the structure heterogeneous. Now, what about immutable? What makes a tuple immutable? Well, recall from an earlier video, we defined immutable as being an object that cannot be modified unless it is being changed entirely. Henceforth, a statement like this, where we're replacing the tuple with a totally new tuple, totally legal. What we cannot do is try to partially modify the tuple, right? I can't try to change just one part of the tuple or a fraction of it. Either replace the tuple entirely or keep it the same. I'll close this video by making one last point about concatenation. Earlier in the video, I made it known that tuples can be concatenated together. However, this statement in particular will not work. When I try to execute it, I get a type error. The reason for that is because this 3 will not be interpreted as a tuple containing just a single value 3. Rather, it'll just be interpreted as an integer. It'll just be interpreted as a 3. And Python does not allow tuples to be concatenated with an integer. In order for this 3 to be seen as a tuple, I need to add a comma after the 3. By inserting the comma after the 3, rather than this simply being interpreted as an integer, the Python interpreter will interpret it as a tuple containing the integer 3. And now that it's considered a tuple, we can now concatenate the 2 tuples together to form one tuple containing all 3 values.